The law of the conservation of energy states that energy cannot be destroyed or created. It can only be changed from one form to another or transferred. In the diagram, you can see how the different types of energy are transferred or transformed. Heat is a form of energy. It is caused by the movements of the atoms and molecules in a substance. Heat transfer occurs when the atoms and molecules collide. When the molecules collide, some of the energy from the faster-moving molecule is transferred to the slower-moving molecule. Heat transfer only occurs from warm to cold. Hot and cold are adjectives used to describe temperature. When finding the temperature of something, you are only finding the heat intensity. What is important is you understand that you are not finding out how much heat something has, you are only finding out how hot or cold it is. Two most common temperature scales used in the HVAC industry are the Fahrenheit scale and the Celsius scale. They are based on the melting of ice and the boiling of water at sea level. It is important that you are able to convert between the two scales. If in the picture of the thermometers they were to show all the temperature hash marks between the temperature ice melts and water boils, the Fahrenheit thermometer would have 180, while the Celsius thermometer only has 100. So for every 5 marks on the Celsius scale, you have 9 on the Fahrenheit scale. Since on the Fahrenheit scale, the melting of ice is at 32, and on the Celsius scale it is 0, you have to add 32 degrees when converting from Celsius to Fahrenheit and subtract 32 degrees when converting to Fahrenheit to Celsius. Also, when looking at the formula, you notice that part of the equation is in parentheses. If you remember from high school, when you're solving an equation, you have to follow the order of operations. So the first thing you would do is solve the part of the equation that's in the parentheses. When talking about how much heat energy something has, we measure the amount in BTUs. The definition of a BTU is the amount of heat needed to raise 1 pound of water 1 degree Fahrenheit. As an example between the amount of heat energy and the temperature of something, a kitchen match contains approximately 1 BTU of heat energy. The temperature when you light the match, though, is between 1100 degrees Fahrenheit to 1500 degrees Fahrenheit. When finding the amount of heat in a substance, what we are doing is calculating how much heat was added or removed to bring the substance to its final temperature. The formula for finding the amount of BTUs that are transferred is to multiply the specific heat capacity of the substance by the mass of the substance by the temperature change. All substances have a specific heat capacity. The definition of specific heat is the amount of heat required to change 1 pound of a substance 1 degree Fahrenheit. If you notice, the definition is very similar to the definition of a BTU. The difference is a BTU is about water. Specific heat capacity is about a specific substance. It takes exactly 1 BTU to change the temperature of 1 pound of water 1 degree Fahrenheit. So the specific heat of water is 1 BTU per pound. The specific heat of iron is 0.129 BTUs per pound. To change the temperature of iron 1 degree Fahrenheit, you only need 0.129 BTUs per pound. If you notice in the formula, there is a triangle and a T. We call that a delta T. What delta T means is it's the difference in temperature. When actually applying the formula, before you can multiply the delta T, you first have to subtract the initial or beginning temperature from the final temperature. At this point, I'd like you to pause here and attempt the 2 problems at the bottom of the slide. The answers are on the next slide. The formula is Q equals C times M times delta T. Q is the answer. C is the specific heat of the substance. M is the mass of the substance, and delta T is the difference in temperature. In step 1, you would put in the known numbers and get 1 BTU per pound times 10 pounds times parenthesis 100 degree Fahrenheit minus 70 degree Fahrenheit parenthesis equals Q. In step 2, you have found your difference in temperature. 1 BTU per pound times 10 pounds times 30 equals Q. In step 3, you multiply your numbers together and you have found your answer. Q equals 300 BTUs. The answer to the other equation is 39 BTUs. Heat transfer occurs 3 ways: conduction, convection, and radiation. Conduction is the flow of heat through a solid or between 2 objects touching. Convection is the flow of heat through the motion of molecules in a fluid. Radiation is the flow of heat by electromagnetic waves. Conduction is the flow of heat through a solid or between 2 objects touching. In the picture, we have a pan sitting on a hot stove element. Since the pan bottom is cooler than the hot element, heat energy is going to be transferred from the stove element to the pan by conduction. Since the pan is a solid, the heat is going to transfer from the bottom of the pan to the inside where the bacon is. And from that point, the heat's going to be transferred to the bacon because by conduction, because the pan and the bacon are also touching. Convection is the flow of heat by the motion of molecules in a fluid. A fluid can be either a gas or a liquid. How it works is as the gas or liquid is heated, it becomes less dense and rises towards the top. The more dense, cooler gas or liquid then falls and gets heated. At that point, you form a convective loop. Radiation is the transfer of heat by electromagnetic waves. It is not, as the book states, done by heat rays. When I hear that term, I think of some science fiction weapon in a movie. Light, microwaves, X-rays, TV, and radio waves are all kinds of electromagnetic waves. When the electromagnetic waves encounter an object, it transfers heat energy to that object. Electromagnetic waves will only move in a straight line. Looking at the picture, you see how the waves are depicted as straight lines. It is because they will not curve around an object. Think about the sun and the earth. Only the part of the earth that is facing the sun receives the light. The other side of the earth is dark. Substances exist in 3 states: solid, liquid, and gas. What state a substance is in is dependent on the temperature, pressure, and heat content. At atmospheric pressure, water remains a liquid from 32 degrees Fahrenheit to 212 degrees Fahrenheit. Below 32 degrees Fahrenheit, it becomes a solid. Above 212 degrees Fahrenheit, it becomes a vapor or gas. Does more heat always make higher temperatures? From what we've said so far, you might be forgiven for thinking that giving something more heat always makes its temperature rise. Generally, that's true, but not always. During heat transfer, heat is either being added or removed from a substance. When adding or removing heat, and there is a change in temperature but no change in state, it is called sensible heat. When adding or removing heat and there is no change in temperature, but there is a change in state of the substance, it is called latent heat. Suppose you have a lump of ice floating in a pan of water and you place it on your hot stove. If you stick a thermometer in the ice-water mixture, you'll find it's around 32 degrees Fahrenheit, the normal freezing point of water. But if you keep heating, you'll find the temperature stays the same until pretty much all the ice is melted, even though you're supplying more heat all the time. It's almost as though the ice-water mixture is taking the heat you're giving it and hiding it away somewhere. Oddly enough, that's exactly what's happening. When a substance changes from solid to liquid or from liquid to gas, it takes energy to change its state. To turn solid ice into liquid water, for example, you have to push the water molecules inside, further apart, and break apart the framework or crystalline structure that holds them together. So, while ice is melting, all the heat energy you supply is being used to separate molecules, and none is left over for raising the temperature. The heat needed to change a solid into a liquid is called the latent heat of fusion. Latent means hidden, and latent heat of fusion refers to the hidden heat involved in making a substance change state from solid to liquid or vice versa. Similarly, you need to supply heat to change a liquid into gas, and this is called the latent heat of vaporization. Latent heat is a kind of energy, and although it may seem to be hidden, it doesn't vanish into thin air. When liquid water freezes and turns back to ice, the latent heat of fusion is given off again. You can see this if you cool water systematically. To start with, the temperature of the water falls regularly as you remove the heat energy. But at the point where liquid water turns to solid ice, you'll find water freezes without getting any colder. That's because the latent heat of fusion is being lost from the liquid as it solidifies, and it's stopping the temperature from falling so quickly. The graph depicts how much heat is transferred to a pound of water at different temperatures in the different states the water is in. When the water is in the solid form, it takes 16 BTUs of sensible heat to raise the temperature from 0 to 32 degrees Fahrenheit. At 32 degrees Fahrenheit, it takes an additional 144 BTUs of latent heat to melt it and change it to water. An additional 180 BTUs of sensible heat is added to raise the temperature to 212 degrees Fahrenheit. It takes an additional 970 BTUs of latent heat to change the water to a vapor. Temperature, pressure, and volume are all related. Temperature and pressure are directly proportional to each other. What that means is if the temperature increases, so does the pressure. If the temperature decreases, the pressure will decrease also. Pressure and volume are inversely proportional to each other. What that means is if the pressure decreases, the volume increases, and if the pressure increases, the volume decreases. Volume and temperature are also related. Just as pressure and volume are inversely proportional, so too are volume and temperature. If the volume increases, the temperature decreases. And if the volume decreases, then the temperature increases. If you think about it, if you put more pressure on something, you are pushing the molecules closer together, so they will hit together more and transfer more heat. If you change the space something occupies, say you decrease the size or volume of area it has, you are forcing the molecules closer together and the temperature will increase.